Welcome to Genetics Decoded. I'm Sharon Palmer, your host. Please note that the information presented in this podcast is for general information only and is not to be considered medical advice. Today we're going to look at genetic testing, how to become a smart consumer in this new landscape. Today we're going to have an in-depth look at genetic testing. There's a lot of confusion in the marketplace. There's a new tool in the marketplace, and very few people have any baseline knowledge around which to make an assessment like, what kind of genetic test do I need? How much is this going to cost? How am I going to use it? And this is across the board. This is not just a lack of knowledge around consumers. It's also a very new tool for practitioners to use. They tend to not have a broad understanding of genetic testing. They might have been introduced to a particular genetic test. They tend to use that in clinic without a lot of understanding about how that may compare and contrast to other genetic tests. What I want to do today is kind of go through, give you some real clarity around, what kind of genetic testing is out there, what is the cost of that testing, and most importantly, the usability, the interpretation of that genetic data so that you can get value, so that you can get some real interesting and valuable information upon which to make some changes to your lifestyle, your diet, your exercise, whatever it may be. In the marketplace, people are really aware these days of companies like 23andMe and Ancestry. So these are companies that are reporting on your ancestry data. So you can do a genetic test. They tell you maybe you're 98% Italian and 2% German. People have a lot of interest in kind of getting this information. And the thing is, once you've got that genetic information, it's good to know around your heritage, but then people go, okay, what am I going to do from there? What most people don't understand is that places like 23andMe and Ancestry do a lot of genetic testing in the background. So on average, there's about 500,000 to 1 million genes that those companies have tested, or genes, I should say SNPs, that have been tested around your health and well-being. They don't report on this genetic data, but it is sitting in the background. And each of these companies will have what's called a raw data file. All of this genetic information will be sitting in this file that can be downloaded, and then you can take it away and use it. So for anyone has already previously done any of this kind of genetic testing, go in and find out whether you've got the raw data file. Not all companies will do that raw data file, but 23andMe and Ancestry will. You can just Google how to download it and you can get that raw genetic data. Anyone who's done a 23andMe, you might need to jump through a few hoops to get that. 23andMe had a major data breach last year. So there was about 14 million users who had their genetic data kind of hacked, which one is of concern, but what has happened post that data breach is that it's much harder for you to get your raw data file. What you will need to do is email. You'll need to actively contact them. They will need proof of your identity, but you can still get that raw data. What you do with it, we will talk about in a little while. So anyone who's done some ancestry screening, you may actually already have some very usable data. 23andMe do a little bit more reporting from a health point of view, but it tends to be more trait information, like why have I got red hair or blue eyes, which isn't going to help you so much from a health perspective. When 23andMe first came into the market a number of years ago, they did some direct-to-consumer reporting, but the FDA in the US kind of shut them down. And the rationale behind that was, do we really want consumers who have very little understanding of their genetics getting this raw genetic data and not understanding what it means, or getting more concerned around the risks and not understanding truly what those risks are. And so the FDA prevented companies like 23andMe going direct to consumer, but the lines are a little bit blurred around that. There is more and more reporting going on. I'm in agreement with people like the FDA, is that I think raw genetic data, that kind of information can give you a lot of insight, but it's also quite technical, it's quite specific. What you want to do is get that data interpreted by somebody who knows what it means. That's where you'll get the most value, and it's where you will get the most insight. Then you've got a direct-to-consumer model. And so this is genetic companies that are not reporting on ancestry, that are just giving you a whole lot of genetic data. And you can order the test directly from them, and then they tend to have a subscription model where you would pay X number of dollars a month. Your raw genetic data would be in there, and they give you some information about that. And again, be cautious here. I've had my genetic test done, I've had my genetic data for over 13 years. As a matter of course, I upload my genetic data into a lot of different sites. Part of that has been to just look at what kind of reporting is going on out there. And what I know is the accuracy of that information varies. I remember having my data uploaded once, I won't name the company, and what happened is I got told that I had this key problem in this pathway. I had done some research in that pathway, and I thought, no, I'm completely the opposite. I know that that pathway works really well for me. So what had happened is this genetic company had misinterpreted the research. They had posted to me that I had a problem. I wrote to that company, I told them that they were incorrect, and then I began to watch what happened. And a little while down the track, it only took them a couple of weeks, but then I went in and I rechecked that information on that particular gene, and suddenly I didn't have a problem anymore. Now, that's good that that information was corrected and updated, but as a consumer, I received no notification that I had been misinformed initially. Let's say you get told that you're lactose intolerant. You don't assume that next week someone's going to tell you that, oh, actually you're lactose intolerant. So you don't think to go back and keep rechecking to make sure that the information that's been presented to you is correct. So again, there's a lot of companies out there reporting on this genetic data. They're not all correct. So you need to be wary of that and aware of that as a consumer. And the thing is, as a consumer, if you've got no baseline knowledge here around genetics and clinical genetics, I guarantee you that your ability to really get value out of your genetic test will be limited. There's a lot of biohacking happening out there, but I know that, again, people have got limited knowledge, and so that will limit their capacity to get value. And then you've got a clinician model, is where you might go off and see your naturopath or your functional GP, maybe even your GP. Things are starting to shift, in which your practitioner will recommend to you that you go and have your genetic testing done. And they won't give you an option. They will usually have committed themselves to presenting a certain genetic test for you, and you will either use it or you won't use it. But if you do, you will be limited to what that particular test offers. They're really the three models that are available. You know, getting that data by proxy through doing your ancestry DNA, ordering it yourself through an online company and then managing how you interpret that data, or going through a clinician, getting the test done, and the expectation would be that they would give you some insight and some guidance on that data and use it to start to change their clinical interventions on your behalf. There are many types of genetic testing out there. And what you want to know is, firstly, what is your what are your goals and objectives? Why are you going down this pathway? Because that's going to make a difference as to what genetic test you begin with. So the first thing is what we call whole genome sequencing. That is where you do everything. Every single base pair is reported. So if we have a look at how much data that is, your whole genome will consist of 3 billion base pairs or 6 billion bases. That is an enormous amount of information. The researchers have gone, if everyone went out and did their genetic test, we actually don't have enough data storage to store that amount of data at this point in time. So it is possible to do your whole genome sequencing. The cost of genetic testing is dropping dramatically. Now, if you wanted to do your whole genome 20 years ago, it would have cost you $100,000. So that's kind of really out of most people's price range. But the price now, so 20 years later, you can get a whole genome test for probably around about $1,000, which is a huge drop. When we look at the cost of genetic testing, it is becoming really accessible for a large percentage of people. But a whole genome on some levels makes a lot of sense. Like if you start by getting every single bit of genetic information that you possibly can, then that data will sit there for you indefinitely for you to be able to use. But right now, being able to use that data is very, very challenging. First of all, where are you going to store it and how are you going to use it? Right now, of all of those 3 billion base pairs, there's a lot of genes that we know nothing about at this point in time. What you will see for a lot of companies is, based on the research, they will kind of take a subsection of this genetic data, and that will be kind of the next step down. But you can order your whole genome. It's not something that's being used extensively at a clinic level right now. I don't really know of anyone using a full genome testing. You know, like where are you going to store it? How are you going to use it? So those would be kind of some real reasons not to go down that pathway. And also knowing too that the cost of whole genome testing will continue to drop. So at some point in the future, when we've got better usability, better storage, it may make a lot of sense. What the next step down is to do some extensive panels in which you would choose a select number of these SNPs, these single nucleotide polymorphisms. That's what 23andMe and Ancestry do. So they take maybe 700,000 to 1 million SNPs and they just take that information and report on that information. That in itself is still a really extensive amount of data. I have my 23andMe and I remember one day thinking, if I printed it, how many pages would that be? And it took my poor little computer forever. And at 10,000 pages, I just kind of shut it down. So you can't, it's still a lot of information. And I get a lot of people at a clinic level saying, I want my raw genetic data. And I always go why? And what are you going to do with it? Because people have the expectation that they're just going to be able to look at that data and it's going to tell them all interesting things. At that point, it's in a very unusable form. You need some sophisticated software in which you would upload that data to in order to interpret it and use it. I think right now, looking at these extensive panels is really the best way to go. It gives you a lot of genetic data to work with. From a cost point of view, it could be anywhere from, $50 to maybe $300. So for very little cost, you can get a lot of very usable genetic data. When I look at the cost of doing those extensive panels compared to the cost of functional testing, so people are doing things like gut microbiome analysis, they're doing urinary metabolites, they're doing their Dutch testing, is a lot of those tests are $300, $400, $500. And so you getting a genetic test for a couple of $100 is incredibly good value. The other really good news is that once you've got that genetic data, you don't need to go back in and redo it. That data is going to sit there. With functional testing, there is the expectation that we will redo the test and check how things change in that process. So an extensive genetic test is a good idea. But this is where you will need to be careful as a consumer, because there's still not a lot of genetic companies that are putting an extensive test into the market. What they tend to do is they're using a much smaller panel. So they may present to you 50 to 100 or 150 single nucleotide polymorphisms. So around about 100 or 150 pieces of this genetic data. Those genes may still be really valuable, that information may still be really valuable to you, but at a clinic level, you need to realise that, depending on what your health condition is, depending on what your health goals are, that genetic data may not give you the information that you need. And I always found at a clinic level, they were too limiting, is that they tended to be one-off reports. You got a whole bunch of information printed in a one-off report, and it was really difficult to use. It was difficult to interpret. A lot of people, if you've had this kind of genetic test, you'll go in, your practitioner will give you maybe a printout. It might be as little as 10 pages, it might be as little as 100 pages, but it will just have all of the genes listed, maybe a little bit of information to go with them, and then your practitioner will sit there and go, oh, you've got this variant here and it means this. And they'll scribble a little note and they'll go, you should do this. And most people get overwhelmed with that. They walk out, they go, I don't know what that all meant. I don't know what to do. The practitioner doesn't know what to do. And you have this enormous amount of really valuable information, but it's not being realised. And that's probably the most common in the marketplace right now, is to have these quite small panels that are presented as a one-off report. You then have companies that are offering even single genes, or they might be offering a panel of like 4 or 5. And the thing that really comes to mind right now is around the MTHFR gene. So there's a lot of podcasters out there who are kind of starting to get into the realm of clinical genetics. The focus is on the MTHFR gene, or they'll say there's 5 or 4 little SNPs in this pathway that you need to get. And I know this because every time a podcaster gets on and talks about the MTHFR gene, we get a whole bunch of calls and a whole bunch of emails saying, I want to do the MTHFR, and do you do these? It's almost like they've got enough information to just ask for key things, but not enough information to know, in fact, how limiting that is. I see practitioners who are building their whole practice upon a single gene, upon the MTHFR. And I think we need to be really cautious here, is that, yes, it's an important gene. And, one of the podcasts we will do really soon is to really go into detail and look around what is going on with the MTHFR gene and around the methylation pathway. But if you're a practitioner thinking that everything that happens to a patient is because of this MTHFR gene, that's not correct. Or that by simply addressing this one small pathway that you will solve everybody's problem, that is also not correct. It is a really important gene and it's a really important pathway, but I would never look at it in isolation. And so, the cost here too, I went and did a little bit of research, and I can see in the marketplace that some people are charging close to $300 just to do the MTHFR genes. And what I know is that you can get close to 1 million SNPs for around $200, $300. From a cost point of view, it doesn't make any sense. But if you're a consumer and you have no idea what is available, then you go, well, that sounds like really good information. let me order it. But then if you want to look any further at any other SNPs in your genes, then what you've got to do is you're going to have to fork out money again. So think of the way that you want to use this data and start with something that's going to be really usable for you over a long period of time. We also are seeing in the market now is that people in preconception care, so people who are looking at having children, are starting to do a lot of preconception screening. And these are the people that are going in to look to see whether there's kind of, the risk of their children having some very unsavoury hereditary diseases. That is very, very different to the genetic testing around health and wellbeing. It's quite specific. It will be offered often through IVF clinics or through genetic counsellors who offer preconception counselling. It makes a lot of sense, especially if you've got some really awful diseases in the family, is to get both, both mum and dad screened so that you can look for these risk factors early. So that's kind of preconception care screening. It's very particular. And then you will see some screening or some panels around particular diseases. So things like Huntington disease. We know that there's a single gene and a single heterozygous mutation that can put you at risk. And so again, you can see GPs going in and screening for these particular genes, even around things like Alzheimer's. So we know that the ApoE4 allele is a risk factor. But it's not the only genetic risk factor. We know from research there's probably around 60, 65 genetic risk factors around Alzheimer's. So looking only at the ApoE4 does not give you enough. But what I really want you to differentiate here between is using your genetic data to look at it from a health perspective. Like, how is it going to help you change your diet, change your lifestyle, adjust your supplementation based on that genetic data, as opposed to looking at disease risk. And the two are very different, and you will often see that they're not presented in the same way in the marketplace. And you would not use a single genetic test to be able to use both of those. And another really common one that people are very aware of, post Angelina Jolie, is what we call the BRCA1, BRCA2 genes. So these are often screened in women who have a high family history of both ovarian and breast cancer risk. They're actually tumour suppressor genes, and again, it's interesting to get that information, but if you get told that you have these risk factors, then a lot of women were choosing to have their breasts removed, to have their ovaries removed, but what people don't understand around the BRCA1 and BRCA2 is that they were risks around ovarian and breast cancer, but because they're working through tumour suppressor factors. So we, as individuals, we're constantly throwing off, our DNA gets damaged, we end up having mutated cells and they replicate, and this is kind of the genesis of cancer. When that happens at a cellular level, your own body and your own immune system is constantly on the lookout for this. Ideally, you want to be able to deal with a gene right at that point of DNA damage. And this is kind of what tumour suppressor genes are doing. They're recognising this, and very early in the piece, they're trying to suppress these tumours. Now, when people have BRCA1, BRCA2 variants, their tumour suppressor function is not working. And so I always go, if you know that, you want to move your focus over to what damages the DNA in the first place. And there's a whole range of other genes that are playing a role in protecting and repairing your DNA. Or if that DNA gets so damaged that you can't repair it, it causes that cell to undergo apoptosis. So I think, again, we've got to be cautious when we get this genetic data as to what our interventions is. Going and removing your breasts and your ovaries is very dramatic, is that we need to also know that there's other factors upstream that you'd want to be focusing in on as well. When we get our genetic data, how it's presented to us is really important. So, as I had mentioned earlier, when it's in its raw genetic state, it's pretty much unusable. It is just thousands of pages of just letters and numbers. You simply can't go in and look at that data and get anything meaningful. Once it's uploaded into software, then it can be reported on. Now, when we look at a single genetic risk factor, what we call a SNP, a single nucleotide polymorphism, there'll be basically three options that will be presented to you. There will be that there's no risk at all, so that will be usually presented as the colour coding green, and that just really means that's the normal presentation of the SNP, is that there's been no change. Now, when we're looking at this genetic data, we get 50% of our genetic information from our mum and 50% from our dad. And we call these the alleles. So for every single SNP that's reported on, mum will be giving you part of that information and dad will be giving you part of it. If you have a green, it means that mum or dad have kind of presented what we call the wild type or the reference allele. Now, if there's been a change, if there's a variant that's reported, that will show up on your report often as an orange. It will be a plus and a minus. So the minus is you've got one normal allele from mum or dad, and you've also got one risk factor. And then if you've got a risk factor from both mum or dad, it will often be presented as a plus plus or the red. But knowing that the change, the variant, is not always the risk. And this is why you've got to be careful about not just looking at that colour coding and going, red is bad and I need to do something. In fact, it might be to your benefit, as we know with being lactose intolerant. Lactose tolerance is the change. You've got to go in and you've got to understand what that genetic data is actually telling you. But getting that genetic data is just the very first step. What you've got to then understand is, how is that changing function? How is that impacting on your health? And then what is the correct intervention? And so your genetic data is just getting that raw information in a way that can be presented to you. Then we have what's called clinical genetics or translational genetics. It's taking that genetic information, understanding what it means, and then going, okay, this is the change I need to make from a dietary point of view. If you find out that you're lactose intolerant, it will be around removing lactose from your diet. This is where you will have the biggest gap in the marketplace right now, is that genetic testing is new to the market. There's very little in the way of postgraduate training in clinical genetics right now. So most of the practitioners who are currently practicing have had no experience or any kind of education around clinical genetics, and if they have, it tends to be very, very superficial. Your practitioner doesn't have a lot of baseline knowledge, and they are then completely reliant on the genetic company that they're using to provide this information. What I know is a lot of the people providing that training have no clinical experience themselves. So you can get a lot of science-based people presenting this genetic data to practitioners, thinking that practitioners are going to get really excited about it because it's going to give them all of this insight. But it doesn't make any sense from a practitioner point of view. So what I'm often seeing happening now is that a genetic test is being promoted as a novelty buy. People are going, oh, I've heard about genetic testing, I want to do the MTHFR gene, or I've gone to see my practitioner and they've told me that they're now doing genetic testing and I should do it. What I see happening over and over again, and I know this for a fact because one of my previous roles was I was working for an international genetic profiling company. My role was to support 400 to 500 practitioners globally around how to help them interpret their genetic data. So what I know is how confused they are. I know that even when they get good information, having that translate into understanding and application, there's a big gap there. And that we would often see that practitioners would get really interested in doing genetics because they understand the value of that genetic data, but it was so difficult to use at a clinical level that they just ended up pushing it to the side. It ended up taking them so long that it wasn't a cost-effective intervention. So we would see 95% attrition rate. So practitioners would go, I'm going to do this. They would find it too difficult and they would stop doing it. Or what you're seeing with practitioners, they do it, they have a quick look, and then they go, okay, now I'm going to just continue to treat you the way that I was. It just kind of gets parked to the side and not used. It's not that the genetic information is not valuable, it's just that the ability to interpret it and use it is really lacking. And that's what you want to really assess the most if you're going down this pathway, is ask those questions like, how long have you been using this at a clinic level? How many SNPs are you reporting on? Am I getting a one-off test, or am I getting something that I can use over time? If you ask the right questions, you will get the information that you need, and then you can go out into the marketplace and you can get something that really is of value for you. And so this is where and this is the whole point of this podcast, is to, what I know is that unless you ask the right questions, you often don't get the information that you need. And I've used clinical genetics. I've used genetics at a clinic level for over 13 years. I know how difficult it is. I know how hard it was initially. I know how much time it took. And I also know the amount of research that it takes in order to use this data in a way that's really meaningful. But I also know that if you can get this information and you can act upon it, it can be game-changing from a health point of view. We know that we're not all the same, that what works for one person doesn't work for another person, but your genetics will give you that insight. I think it's a valuable tool, but you really need to know what you're looking for in the marketplace. One of the other things that's important to understand when you're engaging with genetic testing is around security of your data. Previously spoke to you about how 23andMe had a data breach. The reason this data breach occurred is that when people used their login details, so people would need to use an email and a password. How many of you are using the same password for multiple things? Many. I see this over and over again. So what happened, people were using their password for their 23andMe, that was a password for something else, and this kind of opened up the door to this data breach. So for any of you who have got any access to your genetic data, do not use the same password. Use a complex password that is not used anywhere else. We also see, and this is what I see quite commonly around practitioners, is practitioners will be using or getting people's raw data file. So they might say to their patient, oh, you've done your 23andMe or your Ancestry. If you send me your raw data file, I'll be able to interpret that on your behalf. Now, what that practitioner will do is, because developing your own software to interpret that genetic data is not something that an individual practitioner will do, is they will often go to these direct-to-consumer models that allow you to upload your data and help to interpret. So these practitioners will take their patient's raw data file and they'll upload it to a third-party provider. Now, often this is not disclosed to the patient. So again, if you're a patient and you're handing over raw data, you need to ask the question, what are you doing with my raw data? Because if you don't know that that's being done on your behalf, that is not a good thing. You need to know exactly what is being done with your data, by whom. The other thing I see is that patients who have got their raw data file are just uploading it all over the place. The company says, I won't charge you, and you can just upload it onto our platform. What they're hoping is that you will pay a subscription fee and stay on the platform to keep using that data. And I always say to patients, I go, did you read the terms of service or the privacy policy? Well, of course, do we? Because it's like 30 pages long, it's complex, and we make the assumption, well, I'm sure they're going to do the right thing. But again, you have to ask what is being done with that raw data. You've often signed in with your own name. So again, think carefully around your security. Think about how you're setting up your passwords. Ask the questions of your practitioners. Are you using third-party providers? And if so, you may want to think about whether you want to do that. But if you at least know you've got the choice, and as an individual, be cautious around just handing off your raw genetic data to whomever, and make sure you do read those terms of service and privacy policies. In summary, I think it's a valuable thing to get your genetic data. I've had the opportunity to work with and without genetics. What I know is genetics gives you insight that nothing else will. Know that it's a new product in the marketplace. I think you should see your genetic data as a tool to be used, not an endpoint, not a novelty buy, and make sure that you ask the right questions, do some homework around the costs and around what kind of data you're getting so that you can get something that really is going to be of value to you. Thank you so much for listening to Genetics Decoded. If you enjoyed the episode, please remember to subscribe, like and share. Tell your friends all about what we're doing, because we truly are individuals. Your genetic data can be used for you to make much better decisions around your diet, supplements and lifestyle. Join me each week to find out how.